Hi there. This is Team Mike. And in this presentation, I'm going to talk about two main aspects of our project. What the problem was, and what the project was about, and how we actually ended up solving it, and what we managed to achieve. But to begin with, a quick question. Can we have a quick show of hands of who's driving here to the lab every day? Anyone? No? Okay. How long does it take you to get to the lab? Approximately? And tradition of the lab? Okay. So what is the main issue with driving? It's the amount of time it takes us to get from A to B. So the ultimate aim is to reduce that time. And what is preventing us from getting from A to B quickly? Well, it's the traffic. So the aim of the project is to help people evaluate how we can reduce the amount of traffic. To reduce the amount of traffic, we clearly need to reduce the amount of people on the road. And how do we reduce the amount of people on the roads? Well, many of you will know the symbol. This is the successful scheme implemented in London called the Congestion Charge. Basically, you make people pay. So we use a model of supply and demand to model how the quantity of people on the road relates to the price. So how do we actually do it? We use Google Maps API to display your typical route, and then we let you choose how much do you want to charge people. You put that number in, and then you see some useful statistics about your journeys and how much money you could save. You can also consider alternatives such as public transport. In Cambridge, this would mainly be buses. So you see how much money you can save, and ultimately this is for you to make a decision. So this is intended to be used by the voters of Cambridge to make their mind up about whether they're for or against congestion charge. So here's the actual welcome stream of our app. The user interface is really quite simple, like I've described. You literally add a route, drag a slider to determine the price, and then see some useful statistics. Should keep the slides of statistics. Essentially, the idea is that the more you charge people, basically the quicker you get from A to B. And you can compare how much it would cost you if you use public transport for the entirety of your route. So we use some interesting models. We use the supply and demand to provide us the relation between the quantity generally on the roads and how much you charge people. We use some data from gov.uk to tell you how many people are on the road at a certain hour of day. And then we also have a database which stores lots and lots of routes, pretty much any route in Cambridge. And we store a free flow distance, which is free flow distance and time, which is the time it takes you to get from A to B if there are no cars on the road at all. So then they apply some modifiers to that timing and reduce it. Well, increase it actually, but we make it less than what it is at the moment. So the basic setup is we have some JavaScript running on the client using jQuery, HTML and CSS obviously for appearance, which makes a request to an Apache Tomcat web server running some Java code that accesses the relational database, and that's pretty much the setup of the project. Facebook was an essential communication tool, and you might be wondering what the slide is done up there. Well, that's basically the main interface tool. Now, if we have a little bit of time, then we'll talk a bit about the algorithms that we've been using. One of the basic algorithms is to determine whether a certain location is inside the ring or not, and some others include the optimal reduction of the timing. We probably don't have too much time to go into detail about that. So thank you very much. This is Mike, and hope you enjoy this presentation.